So today we are going to learn about a new technique. So far we have been learning about the fast Fourier transform techniques, and basically we used to compute DFT on basis of that. Now we are going to talk about DIF technique. So DIF stands for decimation in frequency. So in previous topics we were learning about DIT techniques, and right now we are going to focus on DIF, which is decimation in frequency. Now let me just bring out the few differences with respect to DIT technique. It should be clear if you are aware of the steps for DIT. This should be an easy one. So over there, when we are given a problem, we used to first assume what is n. So that n will be determined first. So it could be n4, whatever it is. And then we determine the number of stages m, which could be 3, or as per this condition it could be 2. Then we have to learn about one new thing, and that is the order of the stages. Here the order of the stages will be a bit different compared to stages will be different in comparison to what you have learned in the DIT technique. So in the DIT technique, endpoint DFT came at last, and which was preceded by n by 2, then preceded by n by 4, etc. Here in this case, endpoint DFT will be coming first. Endpoint DFT will be coming first, which will be followed by n by 2, which will be followed by n by 4, which will be followed by n by 8, etc. And in comparison, the number of times it will be done will be 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, etc. So I hope this is a first different point where you have to note this particular stage, the point regarding the order of the stages. Then the fourth point will be the butterfly diagram. With respect to the butterfly diagram also, there is a difference. In comparison with the butterfly diagram of DIT, the difference here lies with the position of the twiddle factor. So if you have the signals here A and B, and you have the -1 factor here, for DIT butterfly diagram, the twiddle factor was placed here, but for DIF, it will be placed here. This W and K, the twiddle factor will be placed here. So that would make this signals at these points, 1 and 2. Signals at this point will be A plus B, and at this point it will be A and minus B, and the whole term will be multiplied with W and K. So it can be written as A minus B of W and K. And this is the basic difference between the butterfly diagram. Here you will be having A plus B on the top arm, and here will be having A minus B, W and K. And the fifth point to be noted here is the regarding the twiddle factor. Regarding the twiddle factor, there is not much of a difference. It's the same thing for end stage endpoint DFT. You will be needing twiddle factors from WN0 to WN n by 2 minus 1. You'll be needing that much twiddle factors. The concept is same, the way of finding twiddle factors and all are same. Now you will have a different case over here. The sixth point, or the regarding the order of the input sequence. Here in the previous DIT technique, you will have remembered the fact that the input was written in bit reversed order and the output was in normal order. But here the concept is a bit different. Input will be in the normal order and output will be in the bit reversed order. These are the 6 points regarding the same concept as used in DIT, but they have minor differences, particularly in the fact of the order of the stages, then the butterfly diagram, and then the order of the input and output. So keeping these points in mind, let us try doing a problem. Let us try doing out the same question that we had already attempted. So we'll be doing this question of find 4-point DFT of x of n 1, 2, 3, 4 using DIT techniques. DIF technique. This is what we have to know about, and obviously we'll be starting to do the problem keeping in mind the different steps. So here n is 4 as you already know, m is also 2 as we already know, but the stages will be different. It will be 4-point DFT first, and which will be followed by 2-point DFT. This will be done one time and this will be done 2 times. The butterfly diagram is to be taken care of. The twiddle factor will be here, W and K, and you have -1 factor here, A and B here. So this will be A plus B, and this will be A minus B of whole into W and K. And then the next thing regarding this would be the twiddle factor requirement. The twiddle factor requirement is all same. So we are finding DFT over here. So W40 is 1 and W41 is -I and W420 is 1. So the twiddle factors required for each of the DFT is also known. And now the input will be in bit reversed order. Input will be in normal order and output will be in bit reversed order. So output, by that concept, you can expect it to be like x of 0, x of 2, x of 1 and x of 3. This is how the input should come. Now we have already done this question and the answer expected is 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. This is the answer that is expected. So let's try to evaluate this particular problem and try to learn about this particular thing. So the input will be returned in normal order. So 1, 2, 3 and 4. They are in the normal order. And the first stage is 4-point DFT. Now when we do the 4-point DFT, we have to connect these two arms and then these two arms. Okay. So the -1 factor will be here, -1 factor will be here. The twiddle factor will be here, W40, and this will be W41. So the twiddle factor, as we had already mentioned, it is W40 here and W41. Since this is the first time that we are doing, let's make a careful analysis on how to do it. So the input is 1 and 3, and you have the butterfly here. The twiddle factor is W40 and here it is -1. You may not need to do this if you are confident, but since we are doing it for the first time, we will do it. So the twiddle factor comes here, so it will be 1 plus 3 over here, and it will be 1 minus 3 W40 here. So this makes it 4 and this makes it -2. So the signal at this point will be 4 and -2. And now we have the second butterfly to solve, which makes it 3 and 4 with 2 and 4 with the W41 here and with the -1 here. So here it will be 2 plus 4 equal to 6, and 2 plus 4 equal to 6, and here it will be 2 and -4 into W41 is -I. So it will be -2 into -I, making it 2I. So here it will be 6 and here it will be 2I. So stage 1 is over. Now we have to do the stage 2, which is 2-point DFT, which will be done 2 times, and you are having this particular signals here. So when we look at this, the twiddle factor butterfly diagram will be here, W20, and this will be W20 here. So it will be -1 here and -1 here. So when we solve this butterfly, we will have 4 plus 6 here, and then we will have 4 minus 6 into W20. Over here we'll have -2 plus 2I and -2 minus 2I into W20. So this will be like 10, and this will be like minus 2, then this will be like minus 2 plus 2i, and this will be like minus 2 minus 2i. So we have the output at this particular stage, and like I mentioned before, we have the output which was already calculated, 10 minus 2 plus 2j minus 2 and minus 2 of minus 2j. Now if you look over here, I have already mentioned that even when the input is in the normal order, output will be in the bit reversed order. So this is x of 0, this is x of 2, this is x of 1, and this is x of 3. So when we do this particular problem, our final solution x of k will be, we have to write the sequence in the normal order, that is 10 minus 2 plus 2i minus 2 and minus 2 minus 2i. So this is the output obtained, and thus we have solved a 4-point DFT numerical using fast Fourier transform using the Dif technique. Hope this is clear.